Today we're going to review finding the greatest common factor and least common multiple. Our objective, or our goal, is to find the greatest common factor and least common multiple of two or more numbers. So in previous tutorials, you've learned how to find the greatest common factor by listing factors and using prime factorization. In addition, you've learned how to find least common multiple by listing the multiples as well as prime factorization. These are two concepts that students often get confused, so I think it's really important to teach them to you together and to review them so that you understand what you're doing and you don't mix them up, especially when dealing with prime factorization. So let's get started. So in our first example, we can see that it tells us to find the greatest common factor and least common multiple of 12 and 18. So first let's start with factors, and we can do this by listing the factors of 12 and the factors of 18. And I'm putting these in different colors just to make sure that you don't get them mixed up. So we'll first start with finding the greatest common factor. Well, my factors of 12 is 1 times 12, then I have 2 times 6, 3 times 4. So 1, 2, 3, 4, 6, and 12. Then I have my factors of 18, which we have, of course, 1 times 18, 2 times 9, 3 times 6. So I've listed them in order just to make them nice and neat. Now we can look at our multiples. So multiples of 12, of course, think multiples multiply. We have 12, we have 24, because 2 times 12 is 24. Then we have 36, because 3 times 12 is 36, 48, and 60. And I'm going to just stop there, and if I need to go on longer, I can, but I usually like to stop after the first few just to double check and compare. So then we have 18, we have 36, and we have 54, 72, and 90. And I'm going to stop there. And really, I could have stopped the second I found a common multiple. But I want to make sure that I'm distinguishing the difference and modeling multiplying by more than just a few numbers. So we start with our factors. We have common factors of 1. We have common factors of 2, we have common factors of 3, and we have common factors of 6. Now, for greatest common factor, we need the greatest, or the largest of those. So in this case, my greatest common factor is 6. So my greatest common factor is 6. Now I need to separate multiples. So I have my multiples. So I have my least common multiple, which is the first one that I see, which is 36. So my greatest common factor between 12 and 18 is 6, and my least common multiple is 36. Make sure you pause this at any time if you need extra time to take notes. Now let's look at another example. Find the greatest common factor and least common multiple of 12 and 42 using prime factorization. So let's start with 12, and we can make our factor tree. We have 3 times 4 is 12, and I have my prime number already. And then, of course, 4 is composite. It can be factored into 2 times 2. So now I have my prime factorization of 12. Looking at 42, I, of course, have 6 times 7 is 42. 7 is prime. And then 6 can be broken into 2 times 3, both of which are prime. So now I have my prime factorization of each number. I'm first going to look at my greatest common factor. Now remember, when we use the prime factorization, the way we approach finding greatest common factor and least common multiple is different. And I really want to distinguish that difference today. We're really going to focus on prime factorization. So greatest common factor, I have to look at common factors I see on both sides. So for greatest common factor, I'm going to keep that in red. And if you want to highlight these in red and blue in your notes or choose any other colors, that's fine. So greatest common factor, we have a 2 and a 2. I have another 2 at the 12, but I don't have it at the 42, so I leave it alone. I have a 3 and another 3. And then I can see I have a 7 on the 42 side, but I don't have it on the 12. So I am done. Then I always encourage students to pick a side, and I always say just stick with the left side. You're only going to multiply those two numbers. So my greatest common factor is 2 times 3. In other words, my greatest common factor is 2 times 3, or 6. Now I'm going to use the same two factor trees and look at least common multiple. Now remember, with least common multiple, we look at each of the different numbers that we have, then we take the highest exponent. So I have a 2, a 3, and a 7. On both sides I'm kind of looking at these as one big tree. Then I take my highest exponent. Well, on this side we have 2 squared times 3. Here we have 2 times 3 times 7. So my highest exponent, of course, is 2 times 2, which is 2 squared. So then I just multiply all the numbers together. So I have 2 times 2, which is 4, times 3, which is 12, and which is 84. So my greatest common factor between 12 and 42 is 6, while my least common multiple is 84. Now you might look at a problem like this and say, I could have just listed the factors. That's true, but I wanted to model using a factor tree. That way you can use the same information to find both answers, often very quickly. But whether you list the factors or use prime factorization, that's really a matter of personal preference, and it also has to do with what kind of numbers you have. Sometimes one method is easier than the other, and that's where you have to make a choice on how you're going to solve it. Moving on to our next example, find the greatest common factor and least common multiple of 18 and 27 using prime factorization. So looking at the greatest common factor and least common multiple of 18 and 27 using prime factorization, we can create our first two factor trees. So we have 18, 27, and again, you might think these are easy numbers to work with, but I really want you to practice the factor trees. So we have 2 times 9 can give us 18. 2 is prime. Let me do that in yellow. And 3 times 3 can give us 9. So now I have my prime factorization of 18. And if you want to rewrite your prime factorization to the side, that's fine. But when you have to look at both greatest common factor and least common multiple, sometimes it's better to keep it on the tree so you have that visual to refer back to. So 27, we of course know 2 plus 7 is 9, so 3 times 9 is 27. And then we can break up the 9 into 3 times 3. So 27, of course, is 3 cubed, one of those perfect cubes. It's a perfect cube. 3 cubed is our prime factorization here, and we have 2 times 3 squared is our prime factorization of 18. So looking at greatest common factor first, which I'm going to put in red again, just so I'm being consistent. Now I have to look at numbers I have in common on both sides for greatest common factor. So I have a 3 and a 3. I have another 3 and another 3. And that's all I have in common is 3 times 3. Remember, just look at one side. So my greatest common factor is 3 times 3, or 9. Now I'm going to look at least common multiple, and I'll keep that in blue. Well, the least common multiple, I just look at the different kinds of numbers. Well, I have a 2, and I have 3 cubed is my highest exponents. So I have least common multiple, I have a 2 and a 3, and my highest exponent is to the third power. Well, we already established 3 to the third power is 27. So 27 times 2, or 27 doubled, which is another way to look at that, is 54. So my least common multiple between 18 and 27 is 54. My greatest common factor was 9. So I hope that helps you looking at your factor trees in 2 different ways so that you're not getting them reversed. Now I want you to take a moment to review your notes, and you're going to compare them with mine. So you'll notice my notes have things highlighted consistently with the colors that I've been using. Of course, you might have chosen different colors. You might want to put something about that in your keys in your notes so that you're reminded of how you're color coordinating your notes if you're highlighting. Otherwise, make sure you have all the information and it's nice and neat so you can read it effectively. Go ahead and pause the video to compare your notes right now. Good job so far. Let's move on to another example. Find the greatest common factor and least common multiple of 36, 48, and 60 using prime factorization. So now we have 3 separate numbers. So I'm going to start with 36. Let me write that a little bit better. And I, of course, can factor that into 6 times 6, both of which are composite and can be factored further. 2 times 3 is 6. 2 times 3 is 6. So now I have my prime factorization of 36. Now looking at 48, I have 4, let me write that neater, 4 times 12. 4 can be broken into 2 times 2, 12, 2 times 6, and 6, 2 times 3. You might have picked different numbers and split it up differently. That's completely fine. So now I have my prime factorization of 48. Last but not least, 60. So of course 6 times 10 is 60. I know that because it ends in a 0. It's a multiple of 10. 6 can be broken down into 2 times 3. 10 can be broken down into 2 times 5. So now I have my prime factorization of 60. Now I'm going to look at greatest common factor first. And again, I'm going to put that in red. So now I have to look at things I have in common with all 3 numbers for greatest common factor. So I can see I have a 2 on all 3. Then I can see I have a second 2 on all 3. And as far as 2's go, that's all I have. Then I can look at my 3's. I have a 3, a 3, and a 3. And as I look, that's where it ends. So my greatest common factor is 2 squared, or 2 times 2 times 3. So when I look at greatest common factor, by the way, I don't worry about exponents as much. I focus on that when I look at least common multiple. So 2 times 3, 2 times 2 times 3, my greatest common factor is 12. And I'll circle that so that it stands out. Now looking at least common multiple. Now I need to look at all my numbers and focus on the highest exponent. And for some people, they like to rewrite the prime factorization of each number. So for 36, I have 2 squared times 3 squared. For 48, I have 2 to the 4th power times 3. For 60, I have 2 squared times 3 times 5. So I need to focus on my highest exponents of my different numbers for least common multiple. So I have a 2, I have a 3, and I have a 5. My highest exponents for 2 is 2 to the 4th power. My highest for 3 is 3 squared, and 5 is just 5. So then I multiply those numbers together. So when you multiply these together, you're going to get a pretty large number. I actually want you to pause the video right now, take a minute, and solve it, and see if your answer matches my own. Go ahead and pause it now. Now on a separate sheet of paper, let's work this out together. So I have 2 to the 4th power first. And remember, these are all multiplications, so you could have done these in any order. So 2 to the 4th power is 2 times 2 times 2 times 2. And I'm just going to go from left to right. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. Then I have 3 squared, which is 3 times 3. Of course, that's going to be 9. And multiply that by 5. So now I've done my order of operations. I've done my exponents first, which is what I need to do. Then, of course, I can either just multiply if I have all multiplication from left to right, or some of you might have said, well, it's all multiplication, so I can do it in any order. As I would do this, of course, I would probably just multiply 9 times 5 first, because that's something you probably know if you know your math facts. So then you'll have 16 times 45, which is a little bit easier to solve. And then my old-fashioned multiplication, I'm going to use a different color for this. 5 times 6 is 30. 5 times 1 plus 3 is 8. Hold my spot. 4 times 6 is 24. Let me cross that out. 4 times 1 plus 2 is 6. And then I can just add up my totals together. You could also have used the distributive property. So I have 0, 12, carry the 1, and 7. So my grand total, when I multiply 2 to the 4th power times 3 squared times 5, is going to give me 720. So that's going to bring us back to our problem. Our least common multiple is 720. So you can kind of see how in this case it might be a good idea to use prime factorization, because finding all those multiples up to 720 would have been a lot more tedious than using the factor trees. So that's why I wanted to show you the last example. So now we're going to look at some real life applications. So we'll look at this first word problem. Samantha has 2 pieces of cloth. I corrected my typo. One piece is 72 inches wide, and the other piece is 90 inches wide. So let's underline important information, or you can highlight important information. She wants to cut both pieces into strips of equal width as wide as possible. How wide should she cut the strips? So we want all the strips to be equal. We also want them to be as wide as possible. So this is one of those problems where we need to ask ourselves a few questions. So we've underlined the pieces of cloth are 72 and 90 inches wide. How wide should she cut the strips so that they are the largest possible equal lengths? So this problem can be solved by using greatest common factor, because we're cutting or we are dividing the strips of cloth into smaller pieces, so we are factoring. So we need to find the greatest common factor. I should actually change the color of these so that I'm consistently being read. So the greatest common factor of 72 and 90. You can do this by listing factors, or you can use a factor tree, which is what I'm going to do. So I'm going to start by factoring 72. I know that 8 times 9 is 72. 8 can be broken into 2 times 4, whereas 9 can be broken into, factored into, 3 times 3, and 4 can be factored into 2 times 2. So now I have my prime factorization of 72. Now I can focus on 90. 9 times 10 is 90, which can be factored into 3 times 3. 10 can be factored into 2 times 5. So I have my prime factorization of 90. So its greatest common factor, so I need my common numbers. So my common numbers I have a 2 here and here. That's it for my 2's. I have a 3 here, a 3 here. I have another 3 for 72 and another 3 under my 90. And then my last number, 5, I don't have in common with 72. So I have all my common factors. So in order to find the greatest common factor, I multiply those together. So GCF is 2 times, and remember, we're only focusing on one side, 3 times 3. So 2 times 3 is 6. 6 times 3 is 18. My greatest common factor is 18. So now I have to look at my question and see how I answer it. So how wide should she cut the strips? Well, Samantha should cut the strips into pieces that are 18 inches wide. So there's my first problem, and I had to approach it using greatest common factor. Let's look at another word problem and see which one we have to find. So now we have Jose exercises every 12 days and Isabel every 8 days. Jose and Isabel both exercise today. How many days will it be until they exercise together? That should be they. There. So how many days until they exercise again together? So first, of course, we need to look at what is the question asking us. Do we have an event that is or will be repeating over and over? Will we have to purchase or get multiple items in order to have enough? Are they trying to figure out when something will happen again at the same time? Those are all questions you would ask yourself, and if you answer yes to those, there's a good chance that the problem has to do with least common multiple. So we notice that we need to find out when they're going to do something again at the same time. So this is a problem where we're going to use least common multiple. So we're trying to figure out when the next time they're going to exercise together. So we need to find the least common multiple of 12 and 8. In this problem, you probably wouldn't use prime factorization. You would probably list the multiples. But I'm actually going to use prime factorization anyway. So I have 2 times 6 and then 2 times 3. So my prime factorization is 2 times 2 times 3. My prime factorization of 8, this is really one that you should kind of know, is of course 2 times 4 and 2 times 2, because this is one of those that's a cube. 2 cubed is 8, and you should kind of memorize that one because you'll probably come across it a lot. So moving on, my least common multiple, I look at all the numbers I have and I take my highest exponents. So I have a 2 and a 3. And my highest exponent, of course, is over here. We have 2 to the 3rd power. And my highest exponent for my 3's is just 3. So my least common multiple is 2 times 2 times 2 times 3. 2 cubed, of course, is 8. 8 times 3 is 24. So my least common multiple is 24. So now, of course, I have to go back to the question and answer it. So Ben and Isabel will exercise on the same day every 24 days. So now I want you to look at your notes once again and compare them with my own. Make sure that you are double checking your work and make sure that you have all the necessary information that you need. Following that, you can come up with your questions, main ideas, and summarize what we've done for today. So go ahead and take a minute to pause to check over your notes right now. So today we looked at finding the least common multiple and greatest common factor of 2 or more numbers. And we used prime factorization and solved the problem in 2 different ways to make sure that you're not getting the 2 confused and to make sure that you're applying the factor trees in different ways and approaching the different problems as needed. So some things to review. Remember, ask yourself some specific questions, especially when dealing with word problems, to figure out if you have to use greatest common factor or least common multiple. If it is a greatest common factor problem, you of course need to say, what is the question asking us to do? Do we have to split things into smaller sections? Are we trying to figure out how many people we can invite to something? Are we trying to arrange something into rows or into groups? Chances are those are problems that have to do with greatest common factor. If it is a least common multiple problem, ask yourself, what is the question asking us? Do we have an event that is or will be repeating over and over? Will we have to purchase or get multiple items in order to have enough of them? Or are we trying to figure out when something will happen again at the same time? Chances are that's a least common multiple problem. So I hope those strategies help you. If you want, you can rewind this video and ask those questions. You're doing a great job. Now enjoy some fun in the sun. Go out and play some sports. No video games. Have a good day, kids.